Hello, linear algebra student. This video is for chapter 5.2, the characteristic equation. What is a characteristic equation? It's actually an equation that can help you to find your eigenvalue. Remember, we talk about eigenvector and eigenvalue in chapter 5.1. And basically, is if I have a matrix or a transformation in a standard matrix, if I have AX equal to lambda x, then x is the eigenvector and lambda is the eigenvalue. And in chapter 5.1, we talk about how to find. If you know a lambda, what is find the eigenvector, and also we would say if I have the eigenvector, how to find lambda. But what about what if I don't have anything? I only have a. How can I find all the eigenvalues? So from the definition, you can see that to find eigenvalues, I would just be looking at this equation. So write lambda as lambda I, and it become factor as a minus lambda I x, because this become a x minus lambda x equal to 0, and a minus lambda x equal to 0, and then lambda is actually just lambda I. So this become um, lambda itself, which is lambda I. In order to solve it, and we say to find eigenvalue, we assume that this is a x. This is an eigenvector, so this must be non-invertible. That means there should be more than one solution. There's some non-trivial solution. As a result, a minus lambda I must be non-invertible with 0 determinant. So this is where the characteristic polynomial comes from. The characteristic polynomial corresponds to a minus lambda I equal to the determinant of a minus lambda I is an expression that you can use to calculate the determinant of a minus lambda I. And it would be in terms of, so this is in terms of lambda. And then the polynomial, the characteristic equation is this particular determinant equal to 0. Because if I have a eigenvector which is non-zero, then a determinant of a minus lambda I must be non-invertible. So after you solve this in terms of I, you would have a solution of lambda. And in this particular chapter, we'll look at real solution of lambda. So in a nutshell, what is a polynomial equation? What is a characteristic equation is a determinant of a minus lambda I equal to 0. So it's related to a. For example, I have 5, 4, 4, 5. Find the characteristic polynomial and then find the eigenvalue. So what is the characteristic polynomial is equal to determinant of 5 minus lambda, 4, 4, 5 minus lambda. Lambda I become 5 minus lambda and 5 minus lambda. So that is equal to 5 minus lambda times 5 minus lambda is 2 pi 2 AD minus BC minus 16. That is equal to 25 minus 10 lambda plus lambda square minus 16. So that is equal to lambda square minus 10x minus 9. No, it's a plus 9. So this is the characteristics polynomial. The equation would say this would work if the determinant is 0. Right? You can factor it. Lambda minus 9, lambda minus 1 equal to 0, lambda equal to 9, and lambda equal to 1. Right? So we have two eigenvalues, 1 and 9. The second one is still a 2 by 2, so characteristic polynomial. You're going to determine determinant of A minus lambda I. That means the determinant of negative 3 minus lambda, 3, negative 10, 5 minus lambda. So that means negative 3 minus lambda times 5 minus lambda plus 30. If I multiply everything out, it will be negative 15 plus lambda square minus 5 lambda plus 3 lambda plus 30. So that become lambda square minus 2 lambda plus 15, right? So if I solve it, so lambda would be 2 plus and minus b squared 4 minus 15 times 4 over 2, which is a complex solution. Complex solution. So because this become less than 0, right? 60 is negative 56, so it's a complex solution, so no real eigenvalue. Okay, so let's do more for a 3 by 3 matrix. So this is this exactly the same thing. So characteristic polynomial is the determinant of A minus lambda I. So that means the determinant of everybody minus lambda, negative 3 minus lambda, 0, 0, 1, 5 minus lambda, 2, 0, 0, oh no, 0, 1, 3 minus lambda. Okay, so expand it out, that would I would need to expand the first row, so it's negative 3 minus lambda times cut the cofactor 5 minus lambda to 1, 3 minus lambda. So you go to negative 3 minus lambda, 5 minus lambda, times 3 minus lambda minus 2, continue, negative 3 minus lambda. This is 15 plus lambda square minus 8 lambda minus 2. So that was negative 3 minus lambda, lambda square minus 8 lambda plus 13, right? So my lambda would be 8 plus and minus b squared, 64 minus 13 times 4, 4ac, all over 2. So it's become 4 plus and minus square root of divided by 2. So this is 63 minus 52. 64 minus 52. 64 minus 13 times 4. Go to 64 minus 13 times 4. 12 over 2. So it's 4 plus and minus root 3. So these are the two. So and then also lambda equal to 3. So these are the three numbers. 3. Well, is it? I think it's negative 3 because yeah, lambda should be equal to negative 3, and 4 plus root 3, 4 minus root 3. One more, 3 by 3. So so we say that it's equal to the determinant of 1 minus lambda 2, 2, 0, 3 minus lambda 1, 0, negative 2, negative 3 minus lambda. Right. I want to expand from the first column, so 1 minus lambda, delete this row and this column, times 3 minus lambda 1, negative 2, negative 3 minus lambda. So that is equal to 1 minus lambda, 3 minus lambda, negative 3 minus lambda, plus 2. That is equal to 1 minus lambda, negative 9. This is a this is a plus. So I don't have plus 3 lambda minus 3 lambda. So and then I have plus lambda square plus 2. So equal to 1 minus lambda plus 2 means lambda square minus 7. So to solve it, so lambda would equal to plus or minus root 7, and also lambda equal to 1 for the factor here. So sometimes you have irrational number, sometimes you don't. You have, you have no solution because they're all complex. Number 6, find the characteristic polynomial of that one. So that means it's determinant of 6 minus lambda, negative 2, 0, negative 2, 9 minus lambda, 0, 5, 8, 3 minus lambda. So that is equal to what? Where can I expand? I expand it through this, right? So it'll be 3 minus lambda, or actually I should say here, 3 minus lambda times positive, negative, positive, negative, positive. So it's still positive. And I delete this row and this column and this row. So 6 minus lambda, negative 2, 9 minus lambda. 3 minus lambda, 6 minus lambda, 9 minus lambda, minus 4. So to solve it, or they just want a polynomial, we can do polynomial. We can solve it actually. 3 minus lambda, and then that would be 54 minus 9 minus 6 minus 15 lambda plus lambda square minus 4. So that would equal to 3 minus lambda. Now lambda square minus 15 lambda. 54 minus 4 plus 50. Is it factorable? 3 minus lambda. Well, let's add. I guess we can do negative, right? Minus 10, lambda minus 5. Yeah. So lambda would equal to 3, 10, and 5. The next thing is another term called the multiplicity of an eigenvalue. To find an eigenvalue from the characteristic equation, we have roots, right? So each algebraic root has a multiplicity. So that is basically the multiplicity of that particular eigenvalue. So if I have lambda minus a, lambda minus b squared in my characteristic equation equal to 0, then we say lambda equal to a has a multiplicity 1, but lambda equal to b has a multiplicity of 2. That means it shows up twice in the solution, in the equation. So let's do the last one. Would be the all eigenvalues. So you can see that this is the upper triangular one. So 5 minus lambda, determinant is actually equal to 5 minus lambda times negative 4 minus lambda times 1 minus lambda and 1 minus lambda square. So this is the what are all the eigenvalues? The eigenvalues are lambda equal to 5, lambda equal to negative 4, lambda equal to 1. Okay, so I'm going to talk about the last topics, which is similarity, in the next video.